Hello everyone, I'm Sarish Mitra from Sri Venkateshwara College of Engineering. I'm a second year student pursuing BE in Computer Science and Engineering. Today, I'll be giving a presentation on the subject stacks. So, what are stacks? A stack is an abstract data type that follows the last in first out principle or called leaf hook principle. Elements are added and removed from one end called the top. Key characteristics of a stack. Supports two primary operations, push and pop. New elements are always added to the top of the stack. Elements can be only removed from the top of the stack. Implementation of a stack using array. A stack can be implemented using an array where the top of the stack is represented by the last index of the array. The push and pop operations can be efficiently performed in constant time. Advantages. First, it is simple and easy to implement. Second, memory is allocated at once. The disadvantage of using stack using an array: fixed size requiring resizing if the stack grows beyond the allocated limit. Memory is wasted if the stack is not full. Introduction of stack operations. Overview of stack operations. Stack supports three primary operations, that is push, add an element to the top, pop, the removal of element from the top, and display, list all the elements present. The basic operations of on a stack can be push, add an element to the top of the stack; 2. Pop, removes and returns the top element of the stack; 3. Peek/top, returns the top element of the stack without removing it; 4. Is empty, check if the stack is empty and returns a boolean value. So the basic three stack operations are defined. Push operation: add a new element to the top of the stack, expanding its capacity for storing data. Pop operation removes the most recent added element from the top of the stack. Display operation shows the content of the stack, displaying each element in order of their insertion. So we'll start with push operation. We'll again discuss explanation of push operation to get it clear with. The push operation adds an element to the top of the stack, increasing its size by 1. Illustration of push elements onto a stack. As the elements are pushed onto the stack, they get stacked one above the other, creating a vertical arrangement. Third, handling of stack overflow. If the stack becomes full and a push operation is attempted, it results in stack overflow, indicating that the stack capacity is exceeded. Pop operation. The pop operation. Explanation of the pop operation. Pop operation removes the top element from the stack, reducing its size by 1. The illustration of popping elements from a stack. When an element is popped from the stack, the element below it becomes the new top. It is removed from the top, which makes the top empty, and the last element before the popped element becomes the top element. Handling of stack underflow. If a pop operation is attempted on an empty stack, it results in a stack underflow, indicating that the stack is already empty. Displaying operation. Displaying operation allows us to retrieve and list all the elements present in the stack, help in debugging and analysis, which means it shows all the products available in the stack. Common use cases for stack, and which is also known as the common applications used for stack. Function calls. Recursion and function hierarchy can be managed using a stack. Call functions are pushed onto the stack while being executed and the pop off after completion. Undo and redo operations. Stacks are often used to implement undo and redo operations that allows users to retrieve or reapply changes in their application, such as editors and graphic design tools. Expressions evaluation. Stacks can be used for evaluate mathematical operations, convert infix notation to postfix notation or prefix, and calculate arithmetic operations. Browser. history. Stacks are used to store URLs in browser history, enabling users to navigate back and forth between web pages. So the applications of stacks is very often used in normalized people, like it is used in women's bangles. Bangles are stacked in one over the other. Books and clothes, you stack books over one over each. Flows in a building, and we don't need to explain that. Browser histories, like last whatever page you searched, it is over and over and over, it goes over again. Mobile phones, companies, tube well boring machines, text editors. Why do we need all of these applications in stack data structure? Stack plays a crucial role in various applications such as expression evaluation, function call management, and undo redo functionalities. It helps us to get whatever is in the stack and whatever we need to push or whatever we need to push out. The summary of stack operations and their significance. As we can see, there's an empty stack over here. It is filled with a 100 size, then a 200 size. We the first element, that is 200, will be popped out, because for using, like if we use pop operation, we can pop out 200. The summary of stack operations and the significance. Understanding the push, pop, and display operations is essential to leverage the power of stacks. Avoid common pitfalls like overflow and underflow. It helps us to get over problems like underflow and overflow, and it helps us to stack data in one line, that is we're using LIFO principle. Thank you, everyone. Please do like, share, and subscribe to this video.